What's going on, everybody? Welcome back to my YouTube channel. Well, look at this nice and beautiful Olympiad question that we have here on the board that we're going to be solving. And the question says, solve the system of equations n to the power of 2 minus m equal to 49 and m to the power of 2 minus n equal to 49. Now remember, there is a condition given to us in the question which says m is not equal to n. Well, our first step towards solving this question will be for us to subtract equation 2 from equation 1. So let's go ahead and do that. So equation 1, I have n squared minus m. Now I'm going to be subtracting the second equation. I'm talking about the left hand side, minus m squared minus n equal to, now moving ahead to the right hand side, 49 minus 49, and that's going to give us 0. Now let's go ahead and open up the brackets. So opening up the bracket, we have n squared minus m squared. Now minus times minus is going to give us plus n equal to 0. So our next step will be for us to rearrange this format, this expression, by writing out the ones with squares first. So this is n squared minus m squared. Now writing the ones without square, this is plus n, and this is minus m equal to 0. Now notice that this expression is a difference of two squares. So I'm going to be expressing this as a difference of two squares, which is n minus m times n plus m. So this is how to express difference of two squares. Now plus n minus m equal to 0. Now notice that n minus m is common. Do you see that? So that means I can go ahead and factorize that out. So let's go ahead and factor that out. So we have n minus m out. Now, what is going to remain here? So n minus m divided by this expression, I have n plus m. So this is n plus m. Now plus, now n minus m divided by n minus m, I'm going to be having 1 equal to 0. So we have two cases. We have this factor multiplying this other factor to give 0. Now let's apply the 0 factor theorem. So this is n minus m equal to 0, or this other one, which is n plus m plus 1 is equal to 0. Now from the first case, let me call this case 1. From the first case, you notice when I move negative m to the right hand side, you see that we have n to be equal to m. Now remember what the question said, m is not equal to n, so they cannot be equal. So we're going to be rejecting this. So we're going to reject this. Now we're going to be solving with this. In this second case, let me call this case 2, n is not equal to m. So let's go ahead and make n the subject by moving every other item like m plus 1 to the right hand side. So n will be equal to, when 1 moves to the right hand side, it becomes negative 1. When m moves to the right hand side, it becomes negative m. So this is n. We're going to be substituting this n in any of the two equations. So let's choose equation 1. So for equation 1, this is n squared. So I'm going to be substituting this expression. So negative 1, negative m, this is for n, and I'm going to be squaring that. Squared minus m equal to 49. So let's go ahead and expand this. So this gives 1 plus 2m plus m squared. So that's it. So expanding this, I have this minus m equal to 49. Now notice 2m minus m gives m. So rearranging this into a quadratic equation, we have m squared plus m. Now moving this 49 to the left hand side, it becomes minus 49. So 1 minus 49 gives minus 48 equal to 0. So we have this nice quadratic equation that we're going to be solving on our next slide. Let's go ahead and do that. Now we're going to be using the quadratic formula to solve this. For example, we know that a is equal to 1, that's the coefficient of m squared. B is equal to 1, that's the coefficient of m, and C is equal to negative 48, which is the constant term. So the general formula we're using is m equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Now let's go ahead and substitute. So we have m to be equal to negative b. That's negative b is 1 plus or minus the square root of b squared, that's 1 squared, minus 4 times a is 1 times c is negative 48. All over 2 times a, that's 2 times 1. So m will be equal to negative 1 plus or minus the square root. 1 squared is going to give me 1 minus, now 4 times 1 times negative 48, I'm going to be having negative 192 all over 2 times 1, that's 2. So m will be equal to negative 1 plus or minus the square root of, now notice that minus times minus is going to give me plus. So 1 plus 192, I have 193 all over 2. So I have two values here. I have m to be equal to negative 1. Let's go ahead with the positive first. Plus the square root of 193 all over 2. Or m is equal to negative 1. Going ahead with the negative the square root of 193 all over 2. Now, how do we get the value for n? You notice by symmetry, the value for m and n is going to be equal to, so I'm going to be writing by symmetry here because the equation given to us in the question is a symmetric equation. So we have m to be negative 1 plus the square root of 193 over 2, and the value for n to be this other value, which is negative 1 minus the square root of 193 all over 2. So this can be a solution, and this also, remember we said by symmetry, this can also be a solution where we have m to be negative 1, negative square root of 193 over 2, and n to be negative 1 plus the square root of 193 all over 2. So these are the solutions to our given equation. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.